Okay, for the first problem, since it's just being, we can just use a distributive property here to make our lives a little bit easier. So we have 6 over I plus 3I over I. 6 over I will simplify by, let's multiply top and bottom by I, so that way we're getting rid of the radical in the denominator for that one. And because I squared, remember, is always going to be equal to negative 1. I squared is equal to negative 1. So with those I squareds being negative 1, that means we end up having a negative 6I. And with the i's canceling here, we get a 3. And in standard form, we would usually write this as 3 minus 6i, a plus bi form. Okay, so that one was a distributive property because on the bottom we just had a single I. On the right-hand side, however, we have a distinct problem. We have 3 minus I in the bottom. So for the purpose of rationalization here, we're going to need to multiply top and bottom by the conjugate of 3 minus I, which is 3 plus I. So we have to do this so that way we can clear the I from the denominator. In the numerator, what are we going to have? Well, 2 times 3 is 6. 2 times I is 2I. Then we'd have an inside of 4 and 3, so that would be a 12 minus a 12i. And then on the last places, we're going to have the minus 4i squared. On the bottom, because these are conjugates, we'll have the first one squared, 9, minus the second one squared. And the second one squared, I squared, is always negative 1. So we do also have this copy of negative 1 on the top. Let's get the red out so we can see this. So it's a negative 1. So it looks like on the top we're going to have 6 plus 4. That would be 10. 2i minus 12i, which is negative 10i. And in the bottom, 9 plus 1, which is 10. So isn't that convenient? It looks like we have, after everything reduces nicely, 1 minus I. See why we like simplification? It looks a lot prettier that way. Okay, why don't you pause the video and try this particular problem on your own. Okay, assuming you gave it a shot here, we're going to multiply this time by the conjugate of the denominator again, but this time the conjugate is 3 plus 4i. Okay, in the numerator, 5 times 3, 15. 5 times 4i is 20i. 2 times 3 is 6i. And in the last place we have plus 8i squared. In our denominator, 3 times, it's a conjugate, so we're multiplying conjugates, so we're just going to have 3 squared, which is the 9, minus 4i times 4i, which would be negative 16. The I squared gives us that negative value even when we square it. So we do still have another I squared here, so that's going to become a negative 1. So in the numerator, it looks like we have 15, and we're going to be subtracting 8 from it, so that's a 7. And then we have a 20 and a 6, so we have a total of 26i, and that's going to be over 9 plus 16, which is 25. So if you ever have a command that says write this in standard form, the standard form of this particular number would be 7/25 plus 26/25 I, and that just follows from the distributive property for the division through the addition.